All right, let's talk about the invisible rulebook that runs our entire universe. We're going to break down three really simple laws that explain pretty much everything. Why planets stay in orbit, why a rocket launches, and, why it's so hard to get out of bed in the morning. We're talking about Newton's laws of motion.
So, to get us started, here's a little puzzle for you. On the one hand, you've got the raw, explosive power of a rocket blasting off into space. And on the other, you've got a cat, just sleeping, napping peacefully. What on earth could possibly connect those two things?
And the answer? It's not some trick question. It's just straight up physics. Turns out, both that rocket and that cat are playing by the exact same set of simple, elegant, and totally unbreakable rules.
And this gets us right to the heart of it all, the big question that Isaac Newton finally cracked centuries ago. Why do things change how they're moving in the first place? The real question isn't what keeps things moving, it's what gets them to start, or stop, or turn. And it all boils down to one simple, powerful idea.
And that one simple idea, it's force. Seriously, that's it. A force is just a push or a pull. Anytime you see something change its velocity, speed up, slow down, change direction, that's called acceleration. And a force is the invisible hand making it happen. Force is the cause, acceleration is the effect.
Now, forces aren't just some abstract thing in a textbook. No way. They are constantly at work all around us. So before we get to the rules of the game, let's meet the main players, the forces you deal with every single day. First up, the big one, the one we all know and, well, feel, gravity. It's that constant, relentless pull the Earth has on everything, just pulling it toward the center. It's what gives things weight and keeps our feet planted firmly on the ground.
Okay, but wait a second. If gravity is always pulling you down, why aren't you falling through the floor right now? The answer is something called the normal force. It's the support force from any surface, that pushback that stops things from just passing right through each other.
And rounding out our top three, we've got tension. Just think of a game of tug of war. Tension is that pulling force that travels through a rope or a cable. And here's the key thing to remember about tension. A rope can pull, but it can never, ever push.
All right, so we've met our players, gravity, normal force, and tension. Now it's time to learn the three fundamental rules they all have to play by. These are Newton's famous three laws of motion. And these three laws, they're not random. They actually build on each other perfectly. They start with an object's natural state, then they explain what it takes to change that state, and finally, they reveal how all forces interact with each other. Let's start with number one, inertia.
Newton's first law is all about inertia. And you can think of inertia as an object's, its built-in laziness. It's a resistance to any change in motion. The more mass something has, the more inertia it has. That sleeping cat is going to stay a sleeping cat unless a force, like you shaking its food bag, makes it move.
Okay, law number two. This is where the action really happens. This is the famous F equals ma. It tells us that if you apply a net force to something, and that just means the total of all the forces added up, it's going to accelerate. And the relationship between them is beautifully simple. If you apply a small net force, you get a small acceleration. But if you apply a large net force, boom, you get a large acceleration. It's totally intuitive, right? The harder you push something, the faster it speeds up. Simple as that.
And now for the third law. This is the one everybody quotes, but it's also the one a lot of people get wrong. It tells us that forces never, ever exist by themselves. They always, and I mean always, come in pairs.
Okay, lean in, because this is the secret sauce. This is what makes it all make sense. While the forces in a pair are equal and opposite, they act on different objects. When you walk, your foot pushes the floor backward, and the floor pushes you forward. A rocket pushes hot gas down, and that gas pushes the rocket up. That's the secret to all movement. So, we know the rules of the game, but how do we actually see what's going on? Well, we use the simple but incredibly powerful tool that lets us visualize all these invisible forces. It's called a free body diagram, and it's basically a physicist's superpower. And making one of these? It's way easier than it sounds. It's just 3 steps. First, you isolate the one object you care about. Let's say a book on a table. Second, you figure out every single force that is acting on that book. And third, you just draw those forces as arrows coming out from the center of the object.
So for our book, we've got gravity pulling it down, and we've got the normal force from the table pushing right back up. See how the arrows are the same length? That means the forces are balanced. The net force is zero, so what happens? Nothing. Its motion doesn't change. It stays at rest. A perfect example of Newton's first law.
All right, you've got the superpower. Now let's use it to solve a classic real-world puzzle, one I guarantee you felt before.
I mean, you know this feeling, right? You step into an elevator, the doors close, it starts to go up, and for just a second, you feel like you've gained weight. That's not in your head, and Newton's laws can tell us exactly why it happens.
Okay, so think about it. When you're just standing still, the normal force from the floor is pushing up on you, perfectly balancing the force of gravity pulling you down. They cancel out. But according to the second law, to accelerate you upward, there has to be a net upward force. That means the floor has to temporarily push on you with a normal force that is bigger than gravity.
And that right there, that's the big reveal. What you feel as your weight is actually the sensation of the normal force pushing up on your feet. So when that force has to increase to lift you, you feel heavier. And when the elevator slows down at the top, that force decreases for a moment, and you feel lighter. It all makes sense.
So let's wrap this all up. What are the key things you should walk away with? First, remember that motion doesn't just happen on its own. Forces cause it to change. Second, Newton's 3 simple laws are the complete rulebook for how that happens. And third, if you learn how to see and draw those forces, you can basically predict how anything is going to move.
But I want to leave you with one last question to chew on. A classic paradox that messes with everyone's head at first. If every single action has an equal and opposite reaction, how can anything ever actually move? Think about it. The answer was hidden right here in this explainer. Thanks for joining me.